Hello everybody, I'm back. This is day 2, so this day right here. The notes are on page 5 through 7, the homework is on page 16. So let's move over to page 5, and you'll notice it looks like this. So you are going to be filling this in while I show this. This is the quadrilateral Venn diagram, alright? So yours looks like this on page 5. Cool. Right, this is the quadrilateral Venn diagram. We are going to go through this entire Venn diagram. So if you notice, there's a lot of little circles and squares and rectangles and all kinds of things that you have to fill in. We're going to start with quadrilaterals, alright? And notice the smaller it gets, the more specific it gets. So quadrilaterals, all of these shapes that we're going to talk about are quadrilaterals, meaning they have 4 sides. And then it gets more specific the smaller it gets. So then parallelograms, and then inside that is rectangle and rhombus. Square is actually in there, but you just can't see it. Oh, there it is. And then trapezoid, and then even smaller is isosceles trapezoid. And then we've got kites, okay? So our first thing I want you to write down is 4-sided figure, that one over there. So that is what a quadrilateral is. And we're going to get more specific as we go, and I'll explain what that means. So all of these shapes are quadrilaterals, and then meaning they all have 4 sides. Okay, so that's what all of them have in common. Now, let's go to this parallelogram box. Parallelogram has 5 things that we need to talk about. And so you are going to fill these in the parallelogram box, but not inside these circles. Alright, so what we have right here are the parallelogram properties. So you can pause the video real quick and write them all down. Okay, now that you've written them all down, let's talk about it. So if you have a parallelogram, you have the opposite sides are parallel and congruent. Diagonals bisect each other. So hopefully we know what the word bisect means. Bisect means to cut in half, so the diagonals cut each other in half. The opposite angles are congruent, and the consecutive angle are. Alright, so for example, I've got my parallelogram here. So we know that the opposite sides are parallel, so this bottom and the top are parallel, the sides are parallel. They're also congruent. So not all 4 sides are congruent. Don't have to be, but top and bottom are congruent, the sides are congruent. The diagonals bisect each other, so that's the diagonal. And then there's another diagonal, so those are going to bisect each other. They're not going to be congruent, but they will cut each other in half. The opposite angles, so this angle and that angle are congruent. And then the consecutive angles, this is the one everyone forgets, so this one's important. The angles that are next to each other, so this one and this one, they're going to add up to 180, okay? This one and that one, they add up to 180. So if they're next to each other, they're going to add up to 180. That's one that a lot of people forget. Okay? Move that off. Now we're going to move to the middle. Alright, so we're going to get even more specific. We've got rectangles now. I know these got smaller, but that's okay. We've got rectangles, so write those down. Pause the video real quick and write that down. Rectangles. I'm going to draw my rectangle. So they have 4 right angles. Notice the parallelogram did not have that. And also the diagonals are congruent. Alright, what's really important about this is that a rectangle follows these 2 properties and all of the rest on this. Okay, so because the rectangle is inside the parallelogram box, it means it follows all of these properties as well. That's what I mean by getting more specific as it gets smaller. So rectangle is in the parallelogram box, it follows these. A rectangle is in the quadrilateral box, it has 4 sides. Okay, so that is the rectangle. Opposite sides are parallel and congruent still. The diagonals cut each other in half. The opposite angles are congruent, and the consecutive angles are supplementary. Alrighty, moving on to a rhombus. Alright, so you can write those down. You can pause the video real quick and write those down. Right now I have my rhombus up there. So what we notice, we have 4 congruent sides. The diagonals bisect the opposite angle. So what we mean by that is when you have a diagonal here, meaning it goes from corner to corner, it cuts this angle in half. So this angle over here is cut in half by this line. Alright, so diagonals look like that and like this. Okay. And they cut each angle in half. And that is only for a rhombus. For rectangles, they have 4 right angles. A rhombus does not necessarily have 4 right angles. Rhombus is basically a square that's kind of squeezed, or you take these 2 corners and squeeze it in or pull them out. That's what a rhombus is. Alright, so that is how that works. Now, what we have going on is for squares. What a square is a rectangle and a rhombus put together. So a square follows all 5 of these blue ones, the blue properties, and all of these orange properties. Alright. So the reason I said there's 5 parallelogram properties is one of the properties is that it's congruent, one of the properties is that the sides are opposite sides are parallel, but we just stuck them together. So it follows all of the orange and all of the blue properties for a square. So you can just take your pencil and take an arrow and point it into the square, or you can rewrite them all. It's up to you. Alright, so that's what a square is. Moving on. Alright, now we got trapezoids. So you can pause the video real quick, get those down. Okay, now we have 2 shapes we're talking about here. A trapezoid that has one set of parallel sides, or one pair of parallel sides. And then we've got an isosceles trapezoid, which has all of these blue properties. So this blue and this orange is followed by the isosceles trapezoid. So really the only difference is you've got 2 congruent legs. So we can take these congruent symbols and put them on the legs. And got parallel, the top and bottom are parallel, and the diagonals are congruent for this. That's important. So if you go diagonal across the shape, that is congruent to that. It would not be the same for just the trapezoid. Alright, make sure you have those written down, and we will move on to kites. Okay, now it's all completely filled in. So write these things down for kites. Now we have our kite. So what is important here is that we have, use the mouse, 2 pairs of consecutive congruent sides. So the top 2 sides are congruent, the bottom 2 sides are congruent with each other. The diagonals form a right angle. So if we put our diagonals in here, they're going to cross at a right angle. That is a unique property to kites, and rhombus, or rhombi. So that's important. And then 1 pair of opposite angles are congruent. So the top and the bottom are going to be, the side ones are going to be congruent. So the left one and the right one are congruent. The top and bottom are cut in half by the diagonals. So that's something good to remember. Top and the bottom are cut in half by the diagonals. Alright, so that is all for these properties. Make sure you have all of them written down. Okay? Now we're moving on to page 6 and 7, so the last part of the notes. So we are on page 6, and it's proving a quadrilateral is a parallelogram. Okay, first things first, let's go ahead and plot this shape. So we've got L, M, N, make sure I plot it correctly, L, N, O. And draw that. Yay. Okay. And we are going to use all of these methods to show that it is a parallelogram. It looks a lot crazier than it actually is. What you really need to know is that you need to find the midpoint of the diagonals. So we'll do that. We need to find if the sides are parallel and equal. Okay, so we do that by slopes and distance. So we just need to find all of that. We need to find slopes of all of them. So LM, MN, and O, and OL. And then the distance, LM, NN, NO, and OL. So these are all of the segments of this parallelogram. Alright. Slopes. Hopefully we remember how to count. So we're just going to count the rise over the run. Well, first of all, LM, slope is 0. It doesn't go up or down. Same thing for NO. Slope is 0. So that's nice. And then we want to count the slope of OL. It goes up 1, 2, 3, 4, 5, and over 2. So 5 halves. And MN goes up 1, 2, 3, 4, 5 over 2. Hey, look at that. 5 halves. So now, I'm going to change colors. I would suggest you do this as well. And we are going to write the evidence. So basically, what do these slopes tell us? Well, slopes tell us that LM is parallel to NO. They also tell us that MN is parallel to OL. So this is the evidence part. This is the important part. Because I know you can find slopes, but I just need you to tell me what the slopes tell you. Okay? Let's go back to distance. What's nice for LM and ON is you can just count. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Great. Those are both congruent. That's good. For this, you can either use distance formula, or I'm going to choose to use Pythagorean theorem. So make a little right triangle. Goes up 5 and over 2. Therefore, I can do 2 squared plus 5 squared equals C squared, which would be OL. So 4 plus 25. The square root of 29 is going to be C. So that's for OL. And then we need to look up here. It goes up 1, 2, 3, 4, 5, and over 2. That's the same. So you don't have to do the math again. You already know what happens when it goes up 5 and over 2. Sorry about that. And then you've got square root of 29. So, what evidence do we have? Evidence. We know that LM is the same as NO, so it's congruent to NO. We know that MN is congruent to OL. So that's what finding the distance has proven. Alright, now we need to find the midpoints. Let's scoot this up. Oh gosh, I can't write. The midpoints of the diagonals. Cool. So, first of all, what are the diagonals? Well, the diagonals go across the shape. So from M to O, from L to N. Remember, it does not matter which letter comes first. You can put ON, you can put NL. Doesn't matter. But we need to find the midpoint. So we've got to remember that formula. X1 plus X2 divided by 2. And then Y1 plus Y2 divided by 2. So we have to take our X's and our Y's, add them together, cut them in half. So averaging our X's and Y's. So for MO, we've got 4, 3, and O is -4, -2. So what we're going to do is we add 4 plus -4 divided by 2, and then 3 plus -2 divided by 2. Look what we have. We've got 0 and 1/2. So there is one of our midpoints. 0 and 1/2. And then for ln, L is -2, 3. N is 2, -2. So -2 plus 2 divided by 2. All I'm doing is plugging into the midpoint formula. And our y is 3 plus -2 divided by 2. Oh, check it out. We've got 0 and 1/2 again. So our evidence is going to be that the midpoints are congruent. Easy peasy. So we need to go back up and make sure that we proved that this is a parallelogram using all of these methods. So that the diagonals bisect each other by showing that the midpoints are the same. Alright? Check. Midpoints are the same. So show that both pairs of opposite sides are parallel by showing they have equal slopes. Great. We showed that. That their slopes are equal, and we showed that they're parallel. Show that they're equal using distance. Yay. Show that one pair of sides is both parallel and equal. Okay? Right here, we did that. One pair of sides, both parallel and equal. Both parallel and equal. So we have solved using all of those things. Alright, for number 2, so we're on page 7. I want you to go ahead and plot the shape, plot the quadrilateral, and then find the slopes, the distances, and the midpoints of the diagonals. Alright, if you're being lazy, stop. Go ahead and find the slopes and the distances. Remember, for the slopes, all you have to do is count. Rise over run. For the distance, you can use Pythagorean theorem. Alright, simplified radical form is what we want for those. But stop your computer right now. Okay, now you can check and see if you got it correctly, and we'll go through the evidence together. So for our slopes, we need to see which ones are parallel. Okay, so which ones have the same slope? PQ is parallel to RS. Yay! This is our evidence, and the second piece of evidence is that QR, so this slope, is parallel to SP. There we go. Alright, for distances, we've got two congruent distances. PQ is congruent to RS, so the opposite sides. And then QR and SP. QR, SP. Yay! The opposite sides are congruent. Great. And for this, we've got midpoints are same. So the midpoints are the same for the diagonals. So we have proved that this is a parallelogram. There is one more for practice. So if you want to practice that last one, you could pause the video right now and then I will show the answers. If you haven't paused it yet, do. And then I circle, or I put boxes around the evidence for this because it's not in a different color. But that is the last one, so this is page 7. Okay, that is your notes for this day. Your assignment is really short. It's just page 16. You turn to that. All you have are 2 of these quadrilaterals that you need to prove to be parallelograms. So just make sure you show all the evidence, and you show the slopes, the distances, and the midpoints of all the diagonals. All right.